Hello, I'm AZKA HASYIM, and in this video, I'll be explaining how artificial intelligence and expert system can help local livestock farmers in Malaysia overcome major challenges in animal health management, and how these technologies can support better decision making in the veterinary sector. So first, let's understand the problem Malaysia's livestock sector is currently facing. The first is climate change. Rising temperatures create new breeding grounds for disease-carrying insects, and livestock under heat stress have weaker immune system, making them more vulnerable to infection. The second is zoonotic disease that jump from animal to humans. Malaysia experienced this firsthand with the Nipah virus in 1999, which claimed over 100 lives. When animal health is poorly managed, it becomes a public health risk. And the third is shortage of veterinary professionals. Most vets are based in cities, leaving rural farmers in places like Kelantan and Sabah to make critical health decisions on their own. This is where AI and knowledge management come in. Knowledge management in the process of capturing, organizing, sharing, and applying expert knowledge so that veterinary expertise can reach any farmer even when the expert isn't physically there. The four stages are acquire, store, share, and apply. AI is what makes this possible at scale. The first technology is IoT sensor monitoring. Wearable devices on livestock continuously track body temperature, heart rate, and movement. If something is abnormal, the farmer gets an alert on their phone, sometimes days before symptoms even appear. A real system doing this is Connectera IDA platform, used in 18 countries with 90% accuracy. The second is computer vision. AI cameras monitor animal behavior around the clock, detecting limping, isolation from the herd, or reduce feeding automatically. Farmers don't need to watch the animals themselves. The system does it for them. The third is predictive analysis. By combining historical disease data with weather patterns, AI can forecast outbreak before they happen. India's NADRAS version 2 already does this, providing disease risk warnings 2 months in advance across 13 major livestock diseases. Malaysia's DVS could adopt the same model. But the most important technology here is the expert system, essentially a digital veterinarian. It has three components: a knowledge base storing veterinary rules, an inference engine that processes those rules, and a user interface for the farmer. Here's how it works. A farmer notices his cattle have high fevers, blister on their hooves, loss of appetite. Then inputs the system into an app. The system applies its rules. If high fever and blisters and appetite loss, then foot and mouth disease is highly probable, and immediately recommends isolating the herd and contacting the nearest DVS office. Expert level guidance available 24 hours a day from anywhere in Malaysia. Now for the second question, the life cycle of this expert system. It follows 7 phases. 1 is the problem identification, to define what the system needs to solve. 2, knowledge acquisition, gather expertise from veterinarian and researchers. 3, knowledge representation, structure and the knowledge into if-then rules the system can process. 4 is the system design, plan the architecture and user interface. 5 is implementation, developers build and code the system. 6 is testing and evaluation, verify the outputs are accurate and reliable. 7, maintenance, update the system regularly as diseases and practices evolve. Among all 7 phases, I consider knowledge representation the most critical. Knowledge acquisition only gathers raw information, but knowledge representation is where the information becomes the logic the system used to make every diagnosis. If the rules are wrong, every output will be wrong. No matter how good the knowledge collected is, if it's represented incorrectly, the entire system fails. It is the bridge between human expertise and machine intelligence. In conclusion, combining AI technologies and expert system within a knowledge management framework can significantly improve livestock health outcomes, reduce disease losses, and build more sustainable agricultural future for Malaysia. Thank you.